That's what goes here. All right, are you ready? See if you can tie everything together.
Period there, you have pi over b, but then above you have, oh,
that's the starting x value.
Okay, gotcha.
Okay, so yeah, tangent's the goofy one. So let's start with cotangent. Build up your confidence a little bit. I have 3 of these. We'll probably do 2 tangent ones. So just one table, one sketch like yesterday. So let's go y equals, let's go 1/3 cotangent 1/2 x. Amplitude is the measurable distance from the axis to the max or the axis to the min. NA. What number is going to show up in our table? The 1/3. Period. It's going to be pi.
Then you have to divide by a half.
Divide by a half,
Which makes it 2 pi.
which will make it 2 pi. So it's stretching it out. Vertical shift? None. Phase? None. So far, so good? Alright, table. 5 key values. We're doing a cotangent. Where do we get our starting x value for cotangent? The phase. All 5 functions except for tangent start at the phase. This is always phase. So that's a 0. Where's it going to finish at? 2 pi. So did not want to make the x's a challenge here. Puts pi in the middle. Pi over 2. 3 pi over 2. Okay, it's cotangent, so I know the first and last y values. Undefined. It's always centered between 2 asymptotes. Und and und. Okay. What's our pattern for cotangent? Max, ax, min. Where's my max going to be at? 1/3. Axis? 0 because I have no vertical shift. And the min? Negative 1/3. Right-handed, staying alive. That's 1, 2, 3, 4, 2 pi. So I know the first and last are my vertical asymptotes. One-third, 0, negative 1/3. And there's concavity. The top part's concave up, so it kind of scoops up. And then after that axis value, the bottom part scoops down when you go toward the min. So concavity switching in the middle there. Good? Okay, let's go. Number 2. So y equals 2 plus tangent 3x. Tangent, not your friend. Okay, amp. NA, but the number that's going to help us in here? 1. Because of right in front of the tangent, there's no number there, so it's a 1. Period. Pi divided by the b, what's the b? 3. Vert. 2. Phase. None. Okay. Table. Okay, everything started at the phase, but now tangent doesn't, because tangent is pulled off of the y-axis to start on this normal equation without a phase shift. So we have to calculate the x1, the starting x value. And I gave you that little formula. Negative pi over 2 is where it would normally start. Divide by the b, add on the phase. So it's negative pi over 2, that's just a part of the formula. Do I have a b number? 3. How much phase do I have? 0. So I don't even need that part. So make this 3 over 1. How do you divide? Flip it over and multiply. What are you going to have? It's going to start at negative pi over 6. So there's our starting x value, negative pi over 6. How do I tell where it's going to end? Add on a period length to see where you land on the number line. So this is going to be your x1 plus the period. So x1 was a negative 1/6. Period is 1/3. So that'll be 2/6. Negative 1 plus 2 is 1/6. So with no phase, it's still going to be centered around that y-axis. So that puts 0 in the middle. What's going next to it? Negative pi over 12. Positive pi over 12. Okay, the y's, I know it starts and ends with an asymptote. And then tangent is min x max. Min x max. Okay, do I have an axis value that's not 0? I should probably start there. My axis is at 2. How far above and below the axis am I going to go because of the amplitude number? 1. So if I'm at 2 and I'm going to a min, where's it going to be at? 1. And the max will be at 3. I'm going to squeeze this graph in down here. Negative pi over 6, pi over 6. Okay, and all those first and last are my asymptotes. If you want to dot in the axis like we've been doing, you can. The axis is at 2. Doesn't have to be there. And now we're ready to put in the 3 other points. It was at a min of 1, an axis of 2, and then a max of 3. And now get your concavity right. From the axis to the max, that's concave up. And I always start at that axis, and I'm going concave down. A little snake going through there. Last one. What haven't we done yet? No, we haven't done any phase shift yet, and we haven't done a flip yet. So, let's throw it all in with tangents. See what we get. There we go. Y equals -2 minus 3 tangent (2x) minus 5. Okay, is it in standard form? Of course not. -2 minus 3 tangent. Taking out the 2, what are you going to have inside? X minus pi over 2. All good there? Amp? NA? Well, what are we going to have to remember when we make our table? 3 with a flip, because of the -3. And a flip always just means switch your max and min. Period. Pi divided by 2. Vert. -2. And phase. Pi over 2. Opposite of what's there, just like always. Okay, the table. Tangent's not your friend because you don't just start at the phase. Tangent starts off center, so we got to calculate it. So the formula is -pi over 2 divide by the b. What's the b? 2. Add on the phase. How much phase do we have? Pi over 2. The phase is this number that we've already done by taking the opposite of it. So adding on the pi over 2. Okay, now I just got to do the work. So think of it as -1/2 multiplied by this reciprocal, and then add on the 1/2. See how I just throw the pi's away and I'll stick them back on later. Well, it'll give us a -1/4 plus 1/2, which gives us a 1/4. So we're starting at pi over 4. And to get the ending value, it's that x1 plus your phase. Well, I'm at a 1/4, and I'm adding on the, not phase, sorry, period. Oof, that was bad. Oh, it turned out to be the same number. Yeah, because the phase and the period happen to be the same. What is period? You want to know where it's going to complete, so you got to go full period length. So the period's 1/2. So where's it going to finish at? 3/4. And now the averaging. Fractions were easy today, didn't get anything tricky. What's halfway between 1/4 and 3/4? Pi over 2. See, this is going to be 1/4 plus 1/2.